Okay, this week we want to look at lesson 5, solving systems graphically. So the first example here I do want to go through, it says the Helm family and the Williams family are going to a book fair. And to get into this book fair, they have to pay a fee. It says Mr. Helm pays entry fees of $11 for 3 adults and 1 child. And Mrs. Williams pays entry fees of $12 for 2 adults and 3 children. So we're going to assume that they're paying the same cost per adult and the same cost per child, but Mr. Williams and Mrs. Williams and Mr. Helm have different amounts of adults and children, and they of course pay different total amounts. How can we solve and figure out what those amounts are that they pay for the per adult and per child? So let's look down below. We're going to let X be the entry fee for an adult, okay, the cost, X dollars is the entry fee for an adult, and Y dollars would be the entry fee for 1 child. So let's break this down. It says the equation, so if we look at Mr. Helm, we don't even need to be given the equation because we know that Mr. Helm is paying a total of $11, okay, and he's for 3 adults, he's paying some dollar amount, okay, so for 3 adults, for every adult he pays X dollars, right? If you go to the Oilers game, you're paying, $100 a ticket times 3 adults, for example. We don't know what the dollar amount is, but it's 3 adults times some X value, and he's got 1 child, so 1 child times some Y value. And of course, we know that 1Y is the same as Y, so we could rewrite this just as 3X plus Y equals 11, okay? The cost of 3 adults plus the cost of the child, unknown, both unknowns to us, is equal to 11. So this is a system where we have 2 unknowns, and that's really the definition of a system. We have 2 linear functions, we have 2 unknowns. So that's how we solve a system, okay? We have 2 unknowns, and we have to solve for both of them. So let's see how we do that. There's Mr. Helm, and then Mrs. Williams. Let's sneak her in here. Mrs. Williams, she's got $12 that she's paid for how many? For 2 adults. So adults we know is X. So let's just do Mrs. Williams in a different color here. So Mrs. Williams is, we've got 2 adults, 2 times X dollars, plus 3 times Y children, 3 children times Y dollars. So as you can see, their total values are different, 11 and 12, and they've got different amounts of children and different amounts of adults. Now, how to solve this graphically? What we're going to do is it says, draw the graphs of the equations 3x plus y equals 11 and 2x plus 3y equals 12 on the grid without using technology. Okay, this calculator, we're not going to use our calculators really at home at all. We'll have to pick that up next year, which is fine. How to graph 3x plus y equals 11? We could use a table of values, very, very cumbersome. And at this point, I'm hoping that you're recognizing that right away, the easiest way to, of course, draw this graph, the line of this equation, this function, would be to change it into y equals mx plus b form. So when I do that with Mr. Helm, I'm going to move over the 3x. And of course, we have y equals negative 3x plus 11. Now, what does that tell me? That tells me that this is the slope, okay? And this is my b value or my y-intercept, which means when x is 0, y is 11. Of course, we've been doing that for a while now. So let's go up. Let's find 0, 11 when x is 0. And of course, this is my x-axis and this is our y-axis. And in this case, x is the cost of adult tickets. Okay, the dollar amount of adult tickets. And here, y is the cost of child tickets. Okay. So we may as well label those values on here. So what this would mean up here, up at 0, 11, that's 11. Notice the scale here. So 10, this is 11 and 12, right? It's going by, this would be 1, 2, 3, 4, 5. Why do we not write the numbers and everyone? It just gets busy, it's cumbersome. Okay, so we just have to notice here. And then if we zip along here, if we were to draw the equation for this line, so I'm going to draw the equation for the line. We've got 0, 11, and then of course the slope is negative 3, or let's just rewrite that. How is that slope? The negative 3, it's the rise over the run, so that's negative 3 over 1. So keep in mind, of course, our rise is negative 3 and our run is 1. And remember with the rise, I always will go down if it's negative, up if it's positive, and I will run to the right to find my first point. So I will go down 3 from 0, 11. 1, I'm just literally counting 1, 2, 3, and run right. So at this point, if I wanted to find more points, I would go down 1, 2, 3, and run right. 1, 2, 3, and run right, and so on. Okay, and there is the line for Mr. Helm. And let's be consistent, I guess, here, and we'll put that in blue. Okay, and I'm going to use my ruler function, okay, my ruler feature on my iPad. And if you've got a ruler, it would probably help for you to use that as well. Let's look at Mrs. Williams. So of course, Mrs. Williams, again, we need to change this equation to y equals mx plus b. We're going to move over the the 2x, I should say. And that's going to become a negative 2x. So now we've got 3y on the left-hand side equals negative 2x plus 12. Right, when we move that over, it becomes a minus. And then we divide everything through by 3. And of course, we have y equals negative 2/3 x plus 4. So our y-intercept here is 4. That means when x is 0, y is 4. So that goes right here on my y-axis. And our slope is negative 2/3. So again, that rise over the run. That rise and the run. So because my rise is negative 2, I'm going to fall 2 and run right. So down 2 and run right 1, 2, 3. Okay, so let's just do that maybe in green. Okay, so here, notice right away that those points overlap. This was one of the points on Mr. Helm's line as well. So I'm going to continue down. If I want to find another point, I would go down 2, 1, 2, 3. So now we've got a few points for that line. Oops, look at that. I got the cheating. I don't even have to be that accurate. This thing's like magic. There you go. Now, if we look along this line, every single point along the blue line will satisfy the Helm equation. So for example, this was 0, 11. This was 1, 8. This was 2, 5, right? Those are the coordinates of that point. This one here is 3, 2. And of course down here, this would be 4, negative 1. Well, of course, we know that this graph really has no meaning in the negatives because no one's going to pay us to take, we're not going to be paid money to take our child to the fair, right? This would mean that the adults would cost $4 and they're going to pay us $1 to take our child. Mr. Helm's going to be paid $1 to take his child to the fair. Probably not likely. If you go to the Oilers game, they're not going to pay you money to bring your children in. You're going to be paying them. So anything in the negatives would not have meaning here or here. So we would just be in quadrant 1 for this question. Okay? So same with the green graph. Likewise, every green point on here would have meaning for Mrs. Williams' family. Okay? This is 0, 4, 3, 2, and this one here is 6, 0. So what that means is if Mrs. Williams was only going to the fair, she could have been charged any of these amounts and those would have totaled up to $12, right? If adults were free, 2 times 0 and 3 times 4 would be 12. Or if adults were, if children were free and adults were $6, 2 times $6 would equal to 12. But the only point that satisfies both Mr. Helm's and Mrs. Williams' equation is this 3, 2. So what does that mean? Let's substitute that in. Let's just do a test here. So Mr. Helm, 3 times 3, because this is of course x and this is y. 3 times $3 plus $2 should be equal to $11. So that's 9 plus 2 equals 11. Is that equal to 11? Sure it is. 11 equals 11. I've just done a check. My left side equals my right side. Perfect. So that means that Mr. Helm is being charged $3 per adult and $2 per child. And that's going to be the same thing with Mrs. Williams. She's also going to be charged $3 per adult. She's going two adults times $3 plus 3 children times $2, and that also equals 12 because 6 plus 6 equals 12. So all of the other points on the line satisfy each individual equation, but the only point that satisfies both is the point of intersection. Okay, so the intersection, the graphs of the equations intersect at a point. What are the coordinates of the point? The coordinates of that point are 3, 2, and it says explain what each of the coordinates represent. 3 is x, that is y. $3 is the cost per adult, and $2 is the cost per child. Okay, so hopefully that makes sense. And that's what a system is. When there are two variables, in order to solve that system, we find the point of intersection between the two graphs. And in the next lesson we're going to start this week, we're going to be doing these algebraically, but we need to be able to do these graphically as well. This is one of the most important concepts for Math 20 and Math 30, as you will see next year. Okay, let's go on to the next example here. I will do this one for you. So here, we're just asked to solve a system graphically by hand. There's no situation. We're just solving two equations. We're just graphing two equations. We're solving a system. So the same idea. I'm going to look at these two equations. I'm going to call this one equation 1, and let's call the second one equation 2. And let's change these. 2x plus y equals 5 is really kind of a useless form to me, right? We could use a table of values. That would take a long time. So let's just look at equation 1, and again we want to change that into y equals mx plus b form. So how do we do that? We rewrite this as y equals, so we move over the 2x rather, so y is negative 2x plus 5. And of course our slope is negative 2 over 1. Where do we start? We start it with our y-intercept, which is 5. So I'm going to go up to 0, 5. When x is 0, y is 5. And our slope is negative 2 over 1. So we go down 2 and right 1, down 2, right 1, and so on. Okay, and then I'm going to draw my line through all those points. Would we need all those points? No, not really. We only need, right, 1 point, or 2 points, 1 point after our y-intercept. Okay, and then let's look at the second equation, which is x minus 2y equals 10. Okay. That's our second equation. And then to solve that, I'm going to, again, move over my x term because I need to isolate y. And here we get, let's just enlarge that a little, negative 2y equals negative x plus 10. Divide everything through by negative 2. And of course, y is equal to the negative divided by negative, of course, you know from grade 6, no, that would be grade 7, is positive 1/2. Okay, and that's x minus 5, right? Positive divided by negative is a negative, so we get a negative 5. And just keep in mind that 1/2 x, right? If we could have left this up here, we could have also rewritten this, okay, as y equals x over 2 minus 5. Notice that these two forms here, and some students kind of don't realize this at first, those are identical. And the reason for that is because 1 over 2 times x, which is really what 1/2 x is, that's x over 1, is just when you multiply fractions, we know we multiply the numerators. 1 times x is x, and 2 times 1 is 2. So 1/2 x is the same as x over 2. So if you're asked in this second form here, well, what's the slope? We know it's a 1 over 2. So your slope is positive 1 over 2. Okay? So just something to kind of clarify a little bit there. So if we look here, we're at negative 5. That's our y-intercept. So we start down here at negative 5 because that's right here. And then we go up 1 over 2. So we literally have to walk 1 and walk 2 to the right. Up 1 and 2 to the right. Oh, looky. And looky here. I'm going to just double that up. That's a double pointer there. Up 1 over 2. And now let's draw that line. So like that. And there's our line. And there's our two equations. And what do you think, bada bing, bada bang, is going to be the solution to this system? The solution to this system would be 4, negative 3. And both of those would satisfy the equation. What does that mean? It means when we verify. So Let's look at the example, the instructions one more time. Determine the solutions by graphing by hand, which we did. That just means graphing by hand versus the calculator. Okay, verify the solution by replacing values into the original equations. So what does that mean? That means we're doing a check. Verify or check are synonymous terms. Okay, synonymous, two words that mean the same thing. So let's do a check over here. I want to check equation 1. You can say verify or you can say check, okay, whatever you would like to write. And I'm going to check equation 1, which was 2x plus y equals 5. Note we want to go back to our original equations, okay? Because the whole idea is, what if I made a mistake and I forgot to put a negative over or something like that? I don't want to use the transformed equation. I want to use the original equation. Always, always. Not 10, 20, 30. If you're doing a check, use the original equation. That's where you go back and check your work. So what was our equation? 2x plus y equals 5. I want to check where x is 4 and y is negative 3. So let's just see if that works. So 2 times 4 plus negative 3 should equal to 5. And does it? Well, sometimes we can write a little line down here. There's various ways to kind of show a check. I'll just maybe leave the line out, or we could, okay, we could do a left side, right side. One of the most important things, and I'll show you in a minute, this is 8 minus 3, and my right side is 5. And 8 minus 3 is, of course, 5. So I'm solving each side separately. And is 5 equal to 5? Yes, it is. Now, this is key, and this seems really picky, but you need to write left side equals right side. If you don't write that in Math 30 on the diploma for trig ratios or for trig proofs, guess what? You lose marks. Isn't that crazy? So even though you have 5 equals 5, so this is critical, and it's kind of a last picky step. You have to just tell me that the left side is equal to the right side. When we get to the second example, or the second equation, it was x minus 2y equals 10. And again, I'm just going to plug in, well, my x value is 4, minus 2 times negative 3 equals 10. So we have to be decent at integers here, right? Negative 2 times negative 3, not just decent, but by grade 10, I'm kind of expecting us to be experts, right, at this point. So if you're struggling with that, that's something where sometimes I'll say, you know, maybe have a little practice, go back and watch a tutorial on YouTube, something like that. Okay, so there's our proof, there's our check, I should say, or our verify, and we've written that left side equals right side because 10 was equal to 10. So we know that 4, negative 3 is the solution to this system. Okay, those are the only two numbers that will satisfy both equations. Okay, now let's look at the next example. And I'm going to let you try this one. So I'm going to have you pause the video and give that one a try. All right then, hopefully you got the same solution as I did, which is 3, 3. So that we know there that x is 3 and of course y is 3. And I did my checks, my verify, even though it didn't ask, that is a requirement of the systems. So there we go, 3, 3. And if you need to pause the video and check your answer, that's fine. Now, steps to solving on a graphing calculator, we'll do that next year. We're just going to skip all that. And we're going to skip this guy here. Here are these special cases. This is quite important, and we've seen some of these already. These need to be graphed by hand. So what this is saying is basically these couldn't be done with a calculator even if we wanted to. Okay, so this says determine the solution to the following system graphically by hand. It's a good way to review these. If we look at the equation y equals 6, so let's look at these separately. If we look at the equation y equals 6, okay, we know that that's this horizontal line. Remember that y equals mx plus b. Well, what happened here when y is equal to 6, our slope was 0, okay? Our mx value is gone. That's because our slope is 0, and that's a horizontal line. So to draw that, let's just choose a color here. Oops, frozen. Okay, let's just draw that using like purple or something. See something. And of course, we know that's our horizontal line where y equals 6. Okay. And that's a function. Remember the vertical line test? If I draw a vertical line anywhere along this graph, I know that it will only touch that line once. Okay, so that of course is indeed a function. And then x equals 2, well, the slope is undefined there. And if I draw x equals 2, remember the hint there, because it can't be written as y equals form, then I know that's a hint that it's not a function. And in fact, it is a vertical line. So if I do the vertical line test on a vertical line, it will touch infinite times. So x equals 2 has an intercept on the x-axis at 2, and we draw that vertical line there. There's the equation x equals 2. Okay? And of course, like I said, this is in fact, right? Let's do the vertical line test. Well, let's do the is it going to touch the pink line more than once? Well, yeah, it's going to touch infinite times, so it's not a function. And I know it's not a function because it can't be written as y equals. Okay? And that's a hint because I couldn't put it in my calculator, right? When you look at the calculator, not that we're doing this year, but you have to change these. Oh, it doesn't show it, but in order to put lines into the calculator, you have to change them to y equals form. So you can never put a non-function into your calculator. Okay, and of course, where is the point of intersection here? Right here, and therefore x is 2 and y is 6. Okay, so there's the solution to that system, 2 comma 6. And let's do another one here. Of course, x equals 2. We just drew x equals 2, so let's draw it again. Okay, x equals 2 would be our vertical line. And we know here we've got y equals 1/2 x minus 1. This is our rise, and this is our run. And we're going to start at -1. Okay, so if we start down here at -1, that's my y-intercept. And if my slope is 1/2, up 1, right 2, up 1, right 2, up 1, right 2. And the place that that happens to intersect is right here at 2, 0. So there's the solution to our system, 2, 0. When x is 2, y is 0. Okay, and that will satisfy both equations. Yeah, let's go on to the next example. The next thing says determine which of these systems has a solution of -1, 1. So here we're given the answer. Here x is -1 and y is 1. Is this question is saying, is this an answer to these systems? What is a system? 2 or more equations put together where you have to solve for both x and y. So we've got 2 unknowns in this case. Okay, it's 2 or more equations. We used to have to do systems of 3 equations where there was an x, y, and a z, but that's no longer in the curriculum. So x and y, what we're doing is we're basically doing a check. I want to check the first equation, and I want to check the second equation. Okay, so I'm going to do this. I'll do 5x plus 6y equals 1. So we're just going to substitute in. Is 5 times -1 plus 6 times 1 equal to 1? Is it? Well, let's see. 5 times -1 is, of course, -5, and 6 times 1 is 6. Is that equal to 1? Sure, -5 plus 6, that's 1, which is equal to 1. So our left side is equal to right side, so I know that -1, 1 would be a solution so far. But I have to make sure because it might not be a solution on the other line. So let's just see, that would be 6x plus 2y equals -3. So that's 6 times -1 plus 2 times 1. So we're just substituting in those values. And we get -6 plus 2 equals, -6 plus 2 is -4. Is that equal to 3? Absolutely not. Left side does not equal to right side. So there's an example right there. You have to check both. So is -1, 1 a solution to that system? No, it is not. Okay, that is the answer. No, it is not a solution. Okay, it is not a solution. Okay, so I know that -1, 1 is on this first line somewhere. It's on the blue line, the 5x plus 6y equals 1, but it's not on the green line at all. Okay, let's look at the next one. Let's try it. Okay, I've got 3x plus 4y equals 1. So I've got 3 times -1 plus 4 times 1. Is that equal to 1? Well, that's -3 plus 4. And of course, 1 equals 1. So left side equals right side. Sure, seems to be on that line. Is -1, 1 on the other line? Let's give it a try. 5x minus 3y equals -8. So 5 times -1 minus 3 times 1 should be negative 8. Negative 5 minus 3. And of course, negative 5, I've lost $5, I've lost 3, I've lost 8. Negative 8 equals negative 8. Yes, left side equals right side. So negative 1, 1 is a solution. Okay? It's a yes. It's a yes bomb. Negative 1, 1 is a solution to the system. Okay? Let's look at the last one. Why don't you try that one? Okay then, so hopefully you got the same thing when I solved here. I got negative 10 does not equal to 10. Okay, negative 7 minus 3. And of course, left side does not equal right side. As soon as I get that, and I know that one of the equations doesn't work, I know that the answer is automatically no. Negative 1, 1 is not a solution to the system. Okay, it might work on the other line, but it's not going to be a solution to the system. Okay, now for this week, for this lesson, I want you to do numbers 1, 3, and 4 only. Okay, numbers 1, 3, and 4. Let me just double check that. 1, 3, and 4. And for this week, the start, sorry about that, number 1, 3, and 4 only. So this is a pretty short assignment, I think, as long as you understand sort of what we're doing. It's just graphing. The other thing I want to do is I want to give you the first part of the password, which is math is. And you can write that all in lowercase letters. Math is. And we'll fill that in on the next video lesson. So math is. Okay? Thank you, and I hope you guys are having a great day. And please contact me if you have any questions.